AOPS counting and probability 15.13. The integers 1, 2, 3, 4, 5, 6, 7, 8 are placed in a list so that each value is either bigger than all the numbers that precede it or is smaller than all the numbers that precede it. For example, 4, 5, 6, 3, 2, 7, 1, 8 is one such list. How many lists are possible? So if we make this number A, B, C, D, E, F, G, H, if we start from the last, G and H, they have to be 1 or 8 since it has to be smaller or bigger than all the numbers that precede it. And if 1 or 8 is anywhere else, then the numbers after wouldn't work. So G or H have to be 1 or 8, so then E and F have to be 2 and 7, same reasoning. C or D, C and D have to be 3 or 6, and A and B have to be 4 or 5. So there's two options for every spot, so every digit or every letter, except for the last one. There's one option because that's the remaining one. So 2 to the power of 7 is equal to 128 options. AOPS counting and probability 15.16. A 3-digit number is created with 3 different digits, randomly chosen from 1 to 5 inclusive. What is the probability that the number is divisible by 15? So if a number is divisible by 15, that means it's divisible by 3 and 5. So in order for it to be divisible by 3, then the sum of its digits must be a multiple of 3, because that's the divisibility rule. And in order for the number to be divisible by 5, the last digit must be 5. Since it's either 5 or 0, that's the divisibility rule, but the digits are from 1 to 5, so it has to be 5. So let the 3-digit number be ABC. ABC is congruent to 0 in modulo 3 because the digits is a multiple of 3. And since C is equal to 5 because the last digit is 5, that means A plus B is congruent to 1 in modulo 3. So that means A plus B leaves a remainder of 1 when divided by 3. So A plus B is either equal to 4, in which A and B is 1 and 3 or 3 and 1, or A plus B is equal to 7, where A and B is equal to 4 and 3 or 3 and 4. So the total number of 3-digit numbers with digits 1 to 5 is 5 times 4 times 3, which is 60, and 4 over 60 is equal to 1 over 15. Since there are 4 choices, AOPS counting and probability 15.19. I have a bag with 5 quarters and 3 nickels. I randomly draw coins out one at a time. What is the probability that I haven't removed all 3 nickels after 4 draws? So 8 choose 4 is 70 combinations of coins that can be drawn since there are 8 coins in total and we need 4 draws. And 5 choose 1 times 3 choose 3 is equal to 5 ways to choose one of the 5 quarters and all 3 nickels after 4 draws. Because there's 5 nickels and you have to draw, no, because there's 5 quarters and you have to draw one of them, and there's 3 nickels and you have to draw all 3 of them. So there's a 5 over 70, which is 1 over 14 chance of drawing all nickels in first 4 draws. But the question asks what is the probability that I haven't removed all 3 nickels after 4 draws. So then we just reverse it. So 1 minus 1 over 14 is 13 over 14 chance of not drawing all nickels in the first 4 draws.